Okay, we got a few people, so I guess we'll start. It's after two. Just to make sure, can you hear me? Thumbs up if you can hear me. Cool, okay. Because it's computers, so people have been complaining about the quality of the recorded version of these classes. So Zoom records this class and then I upload it to YouTube. And it's garbage. I mean, it's like it's 720p with some very big quotation marks around it. So what I'm trying to do right now is I'm trying to use the feed that's coming in with Wirecast or something called Wirecast and actually record with Wirecast so I can get like a somewhere between a 1080 to a 4K feed stream and then upload that to YouTube. We'll see how that goes. Spoiler alert, it will probably be bad. Okay, so today's class is going to be on Ollama. First bit, just so we've done all this kind of stuff, the normal stuff that we do. What is Silicon Dojo? For brand news at Silicon Dojo is authorityless, gatekeeperless, free to end user, hands-on technology education that empowers you to do whatever the hell it is you want to do. Basically, I've been doing tech education since 2009 on YouTube, and the concept is, what if technology education was as accessible as water? What if, I'm going to put this out there, we actually try to empower our populations rather than bankrupt them? That's the idea here. So that's what we're trying to do with this tech education. Free to end user isn't actually free. Basically, the idea is to abstract out the financial component from the educational component. So those are separate things. I don't have sponsors. I don't have Daddy Warbucks or anything supporting this. So if you would like to help support this, you can go to donorbox.org/ETCG and dump a couple of dollars in if you find this to be valuable. I don't push it, don't really focus on it, but if you want this to continue, I need some bucks. I'm going to push this more going into the fall. Right now, I have a lot of stuff going on out of frame. That's a bit of a disaster. So in the fall, we're going to start doing a lot more stuff, and I'll push that concept then. If you have a question, raise your hand, or not raise your hand. I'm sorry. What is it? Raise your hand. I always get this wrong. No, that one. In Zoom, because again, I get a lot of people. I tell them to raise their hands, and then they do this on video. And again, it is adorable, also useless. So make sure to raise your hand, and I will try to answer questions in a reasonable amount of time. Copyright, again, with all this kind of stuff, everything that I'm providing for you, almost everything, is basically free for you to use and reuse as you see fit, even for commercial purposes. One of the concepts with Silicon Dojo is one of the products is the classes themselves, and the bigger product is the idea, the concept of Silicon Dojo. So if you want to modify this stuff to teach your own people, that is great. That is fine with me. Tippy tap or die. So we have a lot of people that come to these classes and they want to become technology professionals, and they think they're going to become technology professionals by sitting in a chair watching videos. And after they watch 40, 50, 500 videos, they will be professionals. That's not how our job works. Our job works by actually doing stuff. Muscle memory, again, much as a real dojo, that is Silicon Dojo. So at the end of this, we almost always have at least 3 labs. You should do these labs. You should do the labs. You should modify the labs. You should do other things. If you are not coding, if you're not actually doing the work, building something, I don't care what, this is just another version of a TV show. Let's see here. Extra help. If you do need extra help, w3schools.com is absolutely fabulous. If you're not gone to w3schools.com, go there. Anything you want to know. How to add something to a list in Python. W3 Schools will tell you. It's nice. It's bullet pointed. It's straight there. W3 Schools is great. And again, for code, do remember ChatGPT is not intelligent. It is not AI. But it is still useful for parsing and things. If you have problems with your code, go to ChatGPT, dump your code in, and it'll tell you you forgot to put in a single quotation mark somewhere. Let's see here. Standardization. So we use VS Code here. You can use whatever the hell it is that you want. Do you remember what the importance of standardization though is if everybody's using basically the same product, it makes it a lot easier to do things like troubleshoot. So at the end, when we have the labs, you can do a screen share with me and I can try to figure out where you're screwing something up if you're having a problem. If everybody's using VS Code, that's really easy to take a look at. If some people are using Notepad++ or whatever, or PyCharm or whatever, again, I will try to figure out where you forgot to put your quotation marks, but it's a lot more difficult if you don't have standardization. It's good for troubleshooting and stuff. Material, if you need any of the material, if you don't see these classes in real time or whatever, or if you want to go over it, if you go to my channel, so it's EliTheComputerGuy.com, or not EliTheComputerGuy.com, that takes you somewhere. But anyways, if you go to YouTube and you go to Eli the Computer Guy, this will be all the videos, not just the classes I've been doing recently, but also the God knows how many classes before then. These are all here. So these are the videos. That's this. And then also there is, if you go to GitHub, github.com/Silicon Dojo /online classes, these are all the notes and the information for all of these different classes. So the lab work, the workbooks, all that kind of stuff is here. I would recommend before you come to the classes that you actually download and print out the lab book. So the lab book is a PDF with all the lab stuff. That's here. And the workbook. And so basically what the workbook is it's all my slides, but it's 3 to a page, and you can print it out and you can write notes. And now I know everybody out there, because I was like that at one time too. You say, I don't need to write notes. I'll remember it. No, you won't. You just won't. Nobody does. Nobody does. And again, trolls, we have not had a huge problem with trolls. We had like one day some bad problems with trolls. Just so you know, how we deal with trolls here is basically everybody is muted unless I allow you to unmute yourself. So that's why you have to raise your hand. And if I see anything stupid going on in the chat, I will just turn off the damn chat. It's very blunt moderation tools here. Stupidity occurs, it goes the hell away for the class. Just so you know, that's how we're going to be dealing with things. And there we go. So I got some people in the class. So we will jump into this. AI and Python Ollama for local large language model AI usage. So exciting. So amazing. So anyways, basically what we're going to be doing today is I'm going to be showing you how to use Ollama. So Ollama is a framework that allows you to run LLMs on your local machine. I'm going to show you how to use Ollama. I want to show you how to connect it with Python. So there's a Python module so that basically your Python scripts are able to communicate with Ollama and basically show you how all of this works. The valuable part of this is you do not need any API keys. You do not need to pay anybody. And, you know, supposedly nobody's spying on you. Again, distrust, verify, stay suspicious. Who the hell knows? But they shouldn't be spying on you. So using something like Ollama can be very useful if you're in lab environments or if you want to play around and do things and you don't want to deal with API keys and dealing with ChatGPT and the whole 9 yards. The system that I'm going to be showing you this on today, the lab system, I don't know if you can see this. This is my old MacBook Pro. So this is a 2018 MacBook Pro with a 2.9 gigahertz 6-core i9 processor. It's got 32 gigs of RAM, and you know, it works. It works. There's working, and then ooh, yeah, it works, I guess. I will tell you with Ollama as a framework really does not give a damn about the hardware you have on your system. You can run Ollama on a potato. It'll just be slow. So that is one thing. So these are the 2012. So when I was doing Silicon Dojo in person here in Asheville, this is one of our lab computers. I have tested Ollama with a 2012, what is that, 12-year-old computer with 4 gigs of RAM, dual core processor, and crappy ass SSD drive. And I will tell you, the small models will work on something like this. So again, that's one of the things to be thinking about whenever looking to buy hardware or whatever. Basically, the question is like, what are you going to be, really running on it? And again, especially for new people, when you're thinking about what kind of lab computer to get, do realize this thing costs 150 bucks. My actual daily driver costs $3,000. What's your budget? That's what you got to ask. And so one of the nice parts is what it will tell you is like with a lot of this LLM, a lot of this practice, you can use small models. Again, small models are fine. It's not what you're going to put into production, but they'll give you decent results. And so you can get decent results and play around with this kind of stuff off of a $150 12-year-old computer if you really want to. So that's one of the things just to kind of keep in mind. Again, I do have my 2023 M2 Max MacBook Pro, 32 gigs of RAM, all that kind of horse crap. I will tell you, it works well on that. I was doing all the labs and all the practice and all that because I do it on my production computer or my daily driver. I was like, wow, this works really well. And then I migrated all the code over my 2018 MacBook Pro and went, wow, this is kind of slow. So yeah, just one of those things to think about with what kind of computer or whatever you need. Let's see here. This still isn't AI. Spoiler alert. We're still not talking about artificial intelligence. I do want you to understand that, right? Because there's a lot of people out there like AI is going to take over the world. And it's like, great, just as soon as you show me some AI, I'll be interested. But none of this horse crap is AI. And I know I talk about anybody that's been coming to these classes for a while knows I keep banging on this like a broken damn record. But this actually matters. This actually matters to real technology professionals, right? Lie to users all you want. If you want to lie to users, go for it. Don't lie to the professionals, right? Basically, AI, artificial intelligence, it is a buzzword for investors. Tech companies, and may not seem like it, they are sucking wind right now because basically most of what we need in the technology world is actually plateauing, and they need to throw out some kind of buzzwords to make investors excited, right? VR didn't get investors excited. Web3 didn't get investors excited. A whole bunch of stuff in the past decade hasn't gotten investors excited. But now they're like, well, maybe AI will get investors excited. And it has gotten investors excited because, again, you hear about all this crap about AI is gonna take over the world and it's an existential risk to humanity and a bunch of scary stuff that has nothing to do with any of this. Why this is important as a technology professional, if you're a new technology professional, in order to solve problems, you need to have a proper frame of reference, right? Just like the users, right? The users are sitting there with their Windows 95 computer, and they're like, why does this computer hate me? You're like, that's stupid. That's stupid. The computer doesn't hate you. It's a Windows 95 machine. It's just a piece of crap. If you understand it's a piece of crap, then you can go in, try to modify a couple of things and make it work a little bit better, right? The computer doesn't hate you because it's a computer, right? Again, when we start talking about AI, if you are trying to solve problems with these technologies based on the idea that any of this horse crap is intelligent, it's going to be very difficult to actually figure out how to solve the problem, right? Because intelligence, right? Intelligence has things like memory. Intelligence has things like understanding. Again, why is it racist? Why is it sexist? It's not. It's not. It's doing statistical analysis off of things called tokens, and it's then turning those tokens into things we call words. It has nothing to do with racism, has nothing to do with sexism, has nothing to do with anything else. Again, right? I think if you think about intelligence, think about all the layers you put on the concept of intelligence. Things like memory. Well, I've already told this intelligence something, so it knows. Yeah, no, but it's not intelligent. Unless you code memory into it, some kind of, memorization process, it's not going to, quote unquote, remember anything. That's a very important thing to be thinking about. Basically, what we're doing with AI is we're turning objects, things, into text. We're turning sensory input into text, right? Because when we're dealing with Python, when we're dealing with these kinds of languages, right, we can parse text. We can do if-else statements on text. We can trigger events based off of text, right? If I have, I don't know, a picture, I don't know, whatever. Like I just have an image of like this. I don't know what the hell to do with that, right? If I have something that tells me weird bald guy holding Apple computer, right, turns that into text, that's something I can actually process off of or do something interesting with, right? And that's all basically with a lot of this AI, there's something called natural language processing, and that's far closer to what we're dealing with this AI stuff than AI at all. The next thing to be thinking about, again, whenever we talk about artificial intelligence, a lot of people are like, oh, Eli, I wish I was that smart. Yeah, I wish I was that smart too. Here's the thing, AI is hard. AI is hard. And again, I will be snarky about Silicon Valley all day long. But the people that are actually designing these systems, building these architectures on the back end, they are brilliant. They might be brilliant rocks, but they are brilliant. All right, here's the thing. We're not dealing with this. We're not dealing with this. Kind of think about like an email server, right? So Exchange server, way back in the day, back when I had my MCSE, I had a buddy of mine going, and she was getting her Exchange server certification. So the Exchange server is an email server within the Microsoft stack, or at least it was. I think it's still around. Anyways, it's a complicated mess. It's a disaster, right? It's their email server, and their backend for the email server goes into databases. Unfortunately, the databases, if they got too big, the entire database would corrupt. So not just one person's emails would corrupt, like everybody's emails would corrupt. And so you need to cluster the backend databases. It was just insane. I was talking to her. She was an MCSE too, and she literally said these two exchange classes were the certifications were the hardest certifications she ever got in her life. Right, being an engineer and not even designing Exchange, just making sure Exchange was running for one company was really difficult. But here's the thing: nowadays, if you go to Office 365, what do? You open an account, you swipe a credit card, you put your name in, you put your email address in, you put a quota or whatever else in, and you hit create, and you have an email account, right? You don't need two certifications that are some of the hardest ones you'll ever get in your life in order to do that. It's Office 365. Anybody can do it. And that's basically what we're looking at with APIs. APIs. The AI is hard. The AI is insane. But the APIs and how we're actually communicating with this stuff is relatively simple. Everything I'm going to be showing you today, is 10, 20 lines of code. And basically, it's 20 lines of copy paste code too. It's really, really actually incredibly simple. Now, the smartest minds of a generation accessed with 10 lines of code. All you need to know how to do is run the 10 lines of code. Okay, let's see here. When we get to Ollama, we're talking about Ollama. So Ollama is a framework for running LLMs on your local system. So this is all going to be run on your local system. Again, this is where we talked about many times is architecture. One of the words I talk about a lot is architecture. Where is a process running? Where is a resource? So for this, we're going to be running it on our local machine, right? So our last classes, we were talking about OpenAI, the OpenAI API. Our Python script on our machine was calling out to OpenAI. All of the complicated processes were happening up in their infrastructure, and then they were sending the response back to us. Basically, with Ollama, we are going to be running everything locally. The good part about that is it all stays local. It doesn't cost you any money, that type of thing. The bad part of it is if you're running a 12-year-old machine, it might be a little bit slow. And again, that's one of the things to be thinking about with architecture. Again, even with like things like AI. Is what is the time frame you want responses for? Can you wait a minute per response, right? So let's say you're coming up with a system, and basically it's just gonna be churning through documents, right? Day after day, week after week, month after month, year after year. You don't really care how long it takes. It's just gonna be sitting there churning through. If you're running that on a local machine, Right, that might be fine. Right, it's gonna take forever and a day for this thing to process all of the documents, but it costs 150 bucks, and that's what your CEO gave you a budget for. That might be fine. On the other hand, again, if you need to do complicated things with quote unquote AI, that's where it might be worthwhile to make that API call. So basically, you upload all of your data, you process on their systems relatively quickly, and you pull it back down. Right? That's something to be thinking about with resource consumption. Um, Hi, where is everyone from? I'm in Atlanta. Can you turn on captions? I don't know how to turn on captions. Do can I turn on captions? I honestly don't know, and it's a little bit late in the class to figure it out. Let's see here. Cool things with Ollama is you can run it from the command line. So basically, just like everything has a shell, right? MySQL has a shell, Linux has a shell, obviously. Everything has a shell. One of the cool things with Ollama is it actually has a shell, so you can get into the Ollama shell. You can tippy tap type out some things and basically see what the response is without having to worry about Python or anything else. It does have a REST API that you can use something called curl to interact with. This will actually be the last thing we talk about in the class today. So one of the things, again, to be worried about with cybersecurity and architecture is when you install Ollama, one of the things that starts up is a web server functionality so that remote systems can actually connect to your system, IP address slash whatever it is with a specific port number. And they can actually send curl requests to your system in order to get responses back. That might be something you want to do, maybe, maybe not. Something to think about from a security standpoint. And then, of course, a Python module. So it's very simple. Python module, import Ollama, then you get a couple of pieces of functionality, and that's how you can interact with Ollama. One of the things to be thinking about when you're using Ollama is all the models that we're going to be using have gone through a process called quantization. There we go. They come up with new words to tongue tie you. Anyways, basically what quantization is in the Ollama world, in the LLM world, is this is where they've taken models and they've compressed them. Right? So basically, when Llama 2 came out, so I don't know, about a year ago or whatever, when Llama 2 came out, I was all excited. I have a MacBook Pro, a cheese grater MacBook Pro. I slapped Llama 2. I went through all the instructions on Llama 2. I installed it on my cheese grater MacBook or Mac and ran my requests. And it took about 5 minutes for that damn thing to process. It's got a Xeon server, a metric crap ton of RAM in it, and, nice GPU in the whole 9 yards. And literally, Llama 2 was taking 5 minutes per request. And the reason is because if you don't tweak, there's things called weights. So when you're setting up an LLM to run on your system, without using something like Ollama. You don't have to use Ollama to do this. You can set it up on your own. There's weights and other settings that you have to configure in such a way so that it'll work worth a damn on your system. Again, that's one of those things. You've got to figure out what the hell that is sometimes. And so basically, if you try to run Llama 2 or anything LLM directly on your system, it might be a bit of a pain. So anyways, so with Ollama, what they do is they do quantization on their models. Basically, this is compressing their models. And what this then means is that when you run these models on Ollama, you will get relatively decent performance. Decent performance. Again, if you're running it on a potato, decent still slow as hell, but it'll actually run. So with the quantization, basically the thing with this is theoretically the results are worse, but it's a bit like a JPEG image, right? JPEG is a compression system for images. And so if you're looking at a JPEG image, it is worse than the original image. Here's the thing, do you care? Do you care? For most people, they probably don't care, but it is something to keep in mind. If you're interested in quantization, you can click on this link or you can go to this link if you have the workbook, and it'll give you this whole spiel on quantization and how that works. Let's see here. The models. Models are trained for specific types of tasks. Smaller models run on worse machines. So when we talk about these models, you'll hear about the 7B model or the 13B model or the 70B model. This is billions of parameters, basically how large the data set is for what it got trained on. And so basically the larger the data set, the more resources it's going to take, right? So Meta came out with something called Llama 3 a little while ago, within the last month or so. I think they came out with a 420B parameter model, which sounds awesome. I literally have no machine that can run that damn thing, though, right? It's so powerful, you can't run it on anything. And so that's something to be thinking about, again, depending on which computer you have, right? You got a gold potato over here. There are small models like a Pi 3. P8i3 from Microsoft is a 3 billion parameter model. That'll actually run on this thing relatively slowly. If you've got, my 2018 MacBook Pro, a 7B model will run on that decently. My M2 Max, a 13B will run on that. And my cheese grater, if I throw in a hell of a lot more RAM, which I don't want to buy right now, can probably run a 70B model. So that's one thing when you sit there and you start playing around with this. Basically, if you get into Ollama and it's running and you do your query or whatever else, and it just stops, not that you get an error, it just stops. And then you go have a cup of coffee, and then you go have lunch, and then you go have dinner, and it doesn't get any further. That's probably not like an error with Ollama failing. That's probably just the model you're using is way too damn big. So just use a smaller model, and that will probably be better for you. Let's see here. One of the things about the models is the models do have licensing. So this is an important thing. So click here, open link. So basically, you can go to Ollama, and I'll show you this in a second. When you go to Ollama.com, there's a little link for models. You can go, and they've got lots and lots of different models. But one of the things that you should be thinking about is licensing. So again, I know a lot of the new technology people, they want to hyper focus on Node and ports and that kind of stuff. And remember, real technology professionals, the licenses are as important as everything else. And so this is something that you're going to have to look at if you're going to be putting any of this crap into production. The thing with Meta's license is interesting. So this is a Llama 3.1 license. Again, they have an 8 billion, a 70 billion, or I'm sorry, a 405 billion parameter. And if you come down here, you can look at the licensing and grants. This tells you where distribution and use. And where is it? If you receive Llama, retain all copies, use your Llama. There we go. And this is where you can get some weird stuff. God bless Mark Zuckerberg. He's not just a jackass to users, he's jackass to the rest of the tech community too. So if you come here, this is the interesting thing about Llama, the Llama model. So you will hear that the Llama model is open source. This is incorrect, right? It is free for most people to use, but that is not open source. And that's where you get to this weird thing here. Additional commercial terms. If on the Llama 3.1 version release date, the monthly active users of the products or services made available by or for licensee or licensee's affiliates is greater than 700 million monthly active users in the preceding calendar month, you must request a license from Meta. And this is the horse crap you get with licenses. And this is why you always need to read your licenses, because you can have some weird stuff in here. Apparently, the reason Zuckerberg put this in there, so basically what Zuckerberg is trying to do right now with this is he's trying to give the middle finger to the rest of the tech industry. It's like one of the big things in the tech world, right, is you've got customers and you have vendors and you have users, but you also have employees, right? You got to make employees excited about what you're doing. So one of the things that Mark Zuckerberg is doing is he's releasing this to basically show that Meta is on the cutting edge of AI so that they can get the best employees. But here's the problem. He doesn't really want to release this to anybody as his actual competitor, right? He doesn't want to release this to Google. He doesn't want to release this, right, to Snap. And apparently that's what this is based off of, Snapchat, where basically they were looking at the monthly active users of Snapchat, and they said, well, we want to release this to the public, but we don't want Snapchat to be able to use it. So that's where they came up with the 700 million monthly users. So that is one of those things just to keep in mind. And again, you've got to read through this licensing to verify what's going on. If you're using this in your lab environment, who the hell cares? Nobody really cares. But again, if you then take this and put this into a production environment, you go into your company with 100, 1,000, 10,000 employees, you start running this at scale, you could run into some big issues if the licensing on the models that you're using are not up to snuff. Basically, in order to get all of this, you can go to Ollama.com. So Ollama.com, and you get your Ollama, right? Get up and running with large language models. You can download and install directly from here. And then for the models, you can click on the models link, and this will bring you just metric crap ton of models, right? Llama 3.1, Gemma 2. So Google Gemma 2 is a high performance and efficient model now available in 3 sizes. So 2 billion, 9 billion, and 27 billion. Mistral Nemo, a state-of-the-art 12 billion model with 128K context length. So that's how many tokens you can put, the entire context of the query that goes back and forth. So that might be a useful thing. But basically, if you go through here, you can see that there are a lot of different versions. And so, again, it's kind of one of those things where you're just going to have to go through and play around with and find, what actually works for you. LLaVA, we're going to use that today. That's actually for image processing. And they've just got tons and tons. Some of these are for like code. Some of these are modified specifically for code, creating code, auditing code, that types of things. But again, you can just go through here and you can see lots and 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 lots of different models that you get to have some fun and play around with. What was this one? Open this. Oh yeah, you get weird ones. So Samantha Mistral. So Mistral is an open source. I think they're actually an open source model. I think they're a company out of France, as I recall. So this is a variation of the Mistral model. Samantha-Mistral, a companion assistant trained in philosophy, psychology, and personal relationships based on Mistral. So there you go. If you want like an assistant that's actually trained on philosophy, psychology, and relationships, Samantha Mistral might be the way to go. Again, I see some stuff going on in the chat. I only scan it while I'm teaching. If you actually have a question, do make sure to raise your hand within the raise your hand within Zoom. Installing Ollama is dirt simple if you're running a Mac. If you're running a Mac, installing Ollama is dirt simple. Again, all you do is you go to Ollama.com, you click on the download link, and then they have some versions for you. So basically, if you go to Mac OS, you can basically download and install for Mac OS, and it should work. No problems. I had no problems doing it. Windows, curiously enough, is still in the preview version. So if you want to download Ollama, they do have a preview version for it. How well it's going to work, who knows? Linux, I can tell you Linux works really well. Basically, to install, they have this curl command. You'll have to see how well this works for you. I know when I was installing this into Ubuntu, I had some issues. So anyways, this is the command supposed to get you to the install. Hopefully that'll work out for you. Again, I know on Ubuntu, Ollama works like a champ. Again, there's just a couple of questions around that actual install process right there. Again, and this is one of the things just to go back to. Again, a lot of people are like, oh, why do you use Mac OS? Oh, you're just a snob. Who the hell owns a computer for cloud? Anyways, apparently folks think like the people like me, I use a Mac because of clout. Like, no, that's just sad. That's just sad. If you buy a computer for clout, uh, anyways, the reason many of us buy a Mac is simply a lot of things just work very seamlessly on Mac. That's just how it is. Scott SEO. Please don't SEO me. Don't SEO me, man. What's up, Scott?
Um, does GPU make a difference with Ollama too?
The GPU should make a difference with Ollama. So the NVIDIA, if you have an NVIDIA GPU, it
I do.
should. Um, Again, it's especially with these kind of classes, it gets to be very difficult because I'm talking to a whole bunch of different people. Basically, I would say, again, with all this kind of stuff, test it, play with it, see how well it works for you. So yeah, if you have a good NVIDIA GPU, these should run better. But as with everything, should has to be within quotation marks. Yeah, so it should be better for you.
Thank you.
Yep. Yeah, that's gonna be the thing with all this kind of stuff in hardware, and that's where, again, especially with GPUs, I get really cautious with GPUs because GPUs are so damn expensive at this point. Do you remember with all of this stuff? Again, we talk about the stack. Whenever we talk about any of these kind of things, the stack is important. And so one of the components of the stack is the hardware stack, the hardware you're running these things off of. So that's going to be your CPU, it's going to be your RAM, it's going to be your GPU, it's going to be your drive, it's going to be all of that kind of stuff. So if you have a platter-based drive with a best-in-class GPU, it's still probably not going to run very well because platter-based drives are pretty damn slow. And so that's going to be one of those things that you kind of have to play around with and see what works better and what works worse. Let's see here. Yeah, so installing, basically just download, you install it. Hopefully it works out well. Hopefully it's a simple install process. Once you've installed it, then you can interact with Ollama at the command line. So you use the command Ollama to basically start your command. Then you can pull a model. So directly from the command line, that's how you pull a model down. You can list the models you have. You can run a model. And of course, to get out of the shell, the most important thing, you do, what is that? \by. \by gets you out of the model. And let me show you how this works now. So I'm actually in a model right now. So let me get out of by. Let's see. Is that big enough for you guys? I guess you can see it. Okay, so we got our command. So this is just a normal command prompt. This is literally just a normal command prompt. So I can do oh mama list. And so I do Ollama list, and so this will show me the models that I have pulled down from their repository. I have Pi 3, it was literally modified 52 minutes ago, and it's 2.2 gigs in size. This is one thing to take a look at when you start downloading these models, again, especially how much storage you have on your system. Some of these models can get big, tens of gigs in size. So if you download 10 of those, bottle up your entire hard drive. So anyways, we have Pi 3, 2.2 gigs, 52 minutes ago. LLaVA, so that's the image one we're going to be dealing with. 4.7 gigs, 3 hours ago I updated it. Pi 1.6, Llama 2, 13B, Llama 2, 7B, Llama 2 simply latest. And this basically just shows you the models that you have already pulled down before you try to interact with them. Let's see, Jock Stroud, what's up?
Hi. So I downloaded this, was probably premature, but I downloaded it yesterday. I saw an earlier video. Downloaded yesterday and tried to pull from my terminal, and I couldn't do anything. And so I was trying to, get ahead of this class today. I'm in my terminal now, and I'm still trying to see how will I pull something like Samantha Mistral from the website because what I've discovered is Llama sits in my application folder. So when I bring up the command line, I guess it pulls from the application, but if I try to pull something from the website, how do I do that?
Well, does it work at all? Can you do Ollama list? Can you get that?
Nope, because I guess I didn't pull all that. So when I did a llama list, it says name, a llama, whatever, ID, size, and modified 21 hours ago. That's it.
Oh, it does say that. Yeah, then I mean all you should have to do if it's running is Ollama, and then you should just do poll, and then I've already done pi, so let's say pi. Anyways, I already have pi, so it checked it out. But yeah, this is all you should have to do. If it's not doing that, that gets into troubleshooting world. I don't know.
So should I try to do pull Samantha Mistral and see if it works?
I would say poll pi. Pi is very small. PHI is only 1.6 gigs. So try to pull pi. If you can run this command, then it's working. If this doesn't work, then it's off to Reddit to you. I don't know.
Okay. All right. Thanks. I'm trying Pi now. And it seems like it's pulling, so I'll see what happens after that, and then I'll try the next one.
Okay, cool.
But it's pulling Pi now.
It's pulling. Yeah, then if it's pulling pi, then it's pulling. Yep, you should be fine. Yep.
Cool.
So yeah, so anybody else out there, Ollama, as far as the framework is concerned, should be pretty simple. Shouldn't be a lot of troubleshooting. It either works or it don't work. So if you install it and if you cannot do Ollama list, that means something went horribly wrong with the install process. I don't know, try to reinstall it again. Otherwise, again, you should just be able to simply pull, like I said, pull this model and it pulls down. If I want to run a model, is really simple. So again, you can use this from the command line. So I simply do Ollama, and then I do run, and then I do whatever model it is that I want to use. So since this one isn't the fastest one in the world, again, I will use that Pi model. You'll see this little circular thing, and then you'll get sent a message. So again, on this machine, if I try to do the 7B, Llama 2 7B, it'll take a little while. If I try to do 13B, it'll take even longer. So what I would recommend when you're playing with this, start with Pi, PHI, and then build up from there. So anyways, you get the arrow, 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 and I don't know, you can just say, hello. You can say, hello, hello, how can I assist you today? Right? And this is all running locally. I can say, what is a PBJ? I even misspelled. What is a PBJ? I apologize, but it seems like there was a misunderstanding. Oops, anyways. What is a PBJ? PBT. Oh, you're killing me. What is a PBJ sandwich? And yeah, then it starts giving you some wow, it's very verbose in whatever the hell it's talking about. Um Yeah, so again, this is why user testing is very important because what in God's let me try to kill this thing. Okay, how about this? Let's say buy, so slash BYE. Okay, so pi was not working out very well. So let's do Ollama run Ollama 2 colon 7B. So this is a bigger model. So this will take a little bit longer. I'm not sure what was going on there with that particular model. Again, user testing is important. So I was using Pi 3 before. So there was Pi and then Pi 3. Maybe Pi 3 is better for sandwiches. I don't know. So what is a PBJ? PBJ can stand for several things. Peanut butter and jelly sandwich, a classic sandwich made with peanut butter and jelly or jam on bread. Personal bank account. So anyway, so now you can see, so you saw with the Pi model, it was spitting out whatever the hell it was talking about relatively quickly. With this, you can see it's actually coming out a lot slower. I can hit Control C to stop this. How do you make a PBJ? Maybe that's a better question to ask it. Making a peanut butter and jelly sandwich, PBJ, is a simple process that requires just a few ingredients and some basic cooking skills. Here's a step-by-step guide to making a PBJ. 2 slices of bread, peanut butter, jelly, jam. Anyways, you get the point. So again, this is all running on the local system, and you can see on the 2018, 32 gigs of RAM, the whole 9 yards. This is literally the speed it is spitting this stuff out with. So you be careful with that. So you Control C and then slash BYE, and then that's how you get out of it. Let's see. Beyond that, we did pull, we did list, we did run, and we did buy. Again, the most important thing out of there is buy slash BYE to get you out of it. So Python. So in order to be able to interact with Ollama with Python, it's relatively simple. You're going to need to install the Ollama module. So you have Ollama. So Ollama is the framework that has to be installed onto your computer. And then beyond that, Python needs the Ollama module installed into that. Again, our standard way of doing it here, because apparently it's better for environments or whatever else, is Python 3 space -m pip install Ollama, and that will install the Ollama module. Ollama must be running. So you probably can't see it from there. But up here, I got a little llama. Ollama has to be running on the system for all of this to work. So basically, you can simply do the Ollama run command and run any particular model you want, and that will get Ollama running. Ollama initially is configured to simply run at startup. So good or bad, it will run at startup. So if you don't screw with it, if you simply install it and then you start playing around and you don't tweak with it anymore, it should always be fine. But if for some reason Ollama is not running on your system, it does have to be running for Python to work. The model has to be downloaded, but the model doesn't need to be running. So we did that Ollama list. So basically in Python, I can select any of the models that have already been downloaded. So they have to be downloaded, but they don't have to run. So Ollama run blah, you don't have to do that. Ollama simply has to be running on the machine with the model loaded, and it'll work. Let's see here. With the prompting, we'll go over take a look at this. So Ollama Python. Basically, as with most of this stuff, it is relatively simple in order to deal with Ollama. So you have roles. So we talked about this before with OpenAI. So if you just look at the default configurations they give you, the examples, you'll notice that they only use user role when they give you the examples for Ollama, but you do have the other roles. So the system role is what character is your computer playing, right? You are a poet. Don't you know it? Right? I want the responses from this to be poetic. And then you have the user roles, and the user roles basically give the damn thing instructions. So role user, limit to 50 words. I highly recommend when you're using Python, especially, that you limit the response to something. Again, with that Pi query that we just did, and it was going on and on and on and on and on, sometimes AI gets a wee bit verbose. So simply putting a limit in there, again, it may be 500. I'm not telling you what the limit is. It might be 5,000. Just tell it to stop somewhere, or you may get a few books. So again, role system, you are a poet. Role user, limit to 50 words, and then role user. This will be the query. This will be the question. Why is the sky blue? In order to do this, you import Ollama. So we import the entire Ollama module. Response equals Ollama.chat. Then we do model, and this is where you plug in the model. Pi 3, Pi, Llama 2, 405B, whatever it is you want to use. I swear. Oh, don't you love Spectrum Internet? I do not like Spectrum Internet. All right, somebody actually use a chat. Where the hell did I stop? Three new messages. AI took over. Okay, well, we'll just start this part again. Welcome back. Yeah, we can take heat. Yeah, I don't know. Spectrum, it really is. I don't know about it is about Spectrum. Yeah, it's 10 till 3. It's 10 till 3. I don't know. Spectrum was doing better. Spectrum was doing better for a while. How we run through this problem. Anyway, just before why sky is blue. Anyways, okay. So these are the roles. System, you are a poet. Role user, limit to 50 words. And the role user, what is our question? What is our query going to be? Again, when you write out this code, as far as Python and as Llama is concerned, we're going to do import Ollama module. Then we're going to do response equals Ollama dot chat model, and then whatever model. Got to put it within the single quotation marks or double. So we're going to be using a Llama 2 7B. So this could be Pi, this could be Pi 3, this could be whatever, 405B, whatever. Then messages. So messages, this is all within a list. Now with this, again, we talk about, especially for the new coders out there, there's a difference between syntax and styling. Right? Syntax is how you have to write code, right? Where indents are, where the delimiters are, that kind of thing. And then there's style. And what style is where you make it your own. And that's right. One of the issues you can get into, and this is something to think about when you get a job with a company, is figuring out what their styling system is. So when we did the classes for OpenAI, everything was in a line. So you do squiggly bracket, role system, comma, content, and whatever the comma is, close squiggly bracket, and that's how the style OpenAI wanted you to use. When you go and you look at what Ollama does and basically what their demonstrations are, this is how they do their styling. What you do, I don't care. Just so you know, the reason that I'm doing it this way is just to keep it within Ollama's version of styling, just so it's a little bit easier when you're trying to read the code, especially if you're new. But again, this is the kind of thing that can be a real pain in the butt, especially when you go into an environment, you have multiple coders. If you have multiple coders all styling in their own way, it can be a bit of a mess to try to figure out what's going on. Then we come down here, we're going to get a response back. So basically this response is going to be a set. We can print out the entire response, or if we want just the message, you do response, message, content. So basically, let me just get rid of that so I can run all of this together. So we want, why is the sky blue? A limit to 50 words, and you are a poet. What will the AI give us back? So it's running, so it does this, and then you do a little dance, as it takes a minute, because it's an older computer. I really was hoping I wasn't gonna have to buy a new MacBook for a while, but I'm starting to think with all this AI crap, I may have to upgrade my other system pretty soon. So anyways, just to show you, this at the end here, is the message that you're looking for. So print, response, message, content. A canvas of cotton candy hues, a masterpiece of Mother Nature's muse, soft and serene, a gentle breeze paints the sky with gentle ease. That is why the sky is blue. So anyways, that's the actual response. If you look at the whole response back, basically, right? So we do model, llama 2, 7B, created at timestamp, message, role, assistant, content, right? So basically here, again, if you start parsing this, you go comma, okay, message. So I want message, open that, comma, content. That's what I want. And so you see response, message, content to print this in. All right. And again, just to show you that it's not, it can do things other than be poetic. Let's see here. You are a scientist. Do I know how to spell? You're a scientist. What would a scientist say about why the sky is blue? Run this through. Do a little dance. There we go. A question close to my heart. The sky appears blue due to a phenomenon called Rayleigh scattering. When sunlight enters Earth's atmosphere, it encounters tiny molecules of gases like nitrogen and oxygen. These molecules scatter the light in all directions. Blase, blase, blase. So again, when you're building these types of AI systems, one of the important things to be thinking about is what is the brand feel for the organization that you're building this product for, right? As a technology professional, it's not simply about giving an answer to 2 plus 2, but is how do you present 4 in a way that this company's users will most appreciate, right? So, if you're dealing with kids, it might be 2 cookies plus 2 cookies equals 4 cookies, right? Yay! Right? You got some Sesame Street branding going on. If you're super serious scientists, I don't know, you have something else, right? But anyways, that's where you can go to the role. And this can help try to present the answers in a way that's most appropriate for your users. The other thing to be thinking about too, again, you're seeing how long it's taking on this particular system. Again, when we start talking about things like hardware resources and cost, one of the things you need to be thinking about is the end user and what latency, how long do you have to present a response? Right. So if I create a web application, so let's say I create a web application, this web application can use AI to answer questions for my customers. I want them to hit submit and as quickly as possible get a response back. Right. So if I'm creating an AI for my customers, I am willing to spend the money on a $40,000 GPU and a $200,000 server because every person that's asking a question is literally asking a question so that they can hand me money. When are you open? Are you open at these times? I would like to buy this. How does your return policy work, right? When those people are asking those questions, they want a response as quickly as possible. And so the hardware that's delivering those responses, it really, really, really matters. On the other hand, to be thinking about though, like I say with this kind of thing, if you just, let's say you have a database with just a massive amount of data, and you just want to go through there and you want to do something with that data that's there, and again, you can just simply churn along forever and ever and ever and ever and ever, then again, the latency for the responses might not necessarily matter. So that's an important thing to think about. But yeah, so this is literally, woohoo, you're doing AI. You download Ollama, you make sure Ollama's running, you install the Ollama module, you copy and paste this, you have now done AI. And that's literally all there is to it. Again, we're going to have more classes going in the future. Again, we're going to use this as a part of larger projects. But voila, you know now AI. You now know AI. Oh, Jock Stroud. What's up, Jock?
All right. So an example you just said, like you, so you're creating the website and you invested 40 in GPUs and things like that. So you're able to get the llama going to get faster.
Yep.
But you're creating this for customers who may not have those systems. So is there any way in the programming you can kind of like make the answers come as fast as yours would, or it totally depends on the hardware that you think your customers might use? If you kind of get my question.
Yeah, that goes into a big, long, tedious discussion with customers. Why I'm glad I don't have customers anymore. So if you're going to be building this type of thing, that's where you go through. There's a whole requirements process. So you sit down with a customer, basically you ask them, what are they looking for? What performance are they looking for? Most importantly, what budget they're looking for, a whole bunch of other things. And so basically, as you sit down and you go through that process, that's where you kind of figure all of this kind of stuff out. So basically, if they come to you and they go, look, we need this kind of system. We know we're looking at, X amount of traffic per hour, per minute, or whatever. We have a $500,000 budget. Then you can sit down and you can try to sketch out what you think the appropriate solution should be. If they come to you, they're a mom and pop shop, and they go, look, we can spend about $3,000 on this project all told. And that's where you start looking at it. Again, that's where you start trying to figure out where to allocate resources, right? If you've got $500,000 to play with, you can take a lot of those resources for yourself and spend some on hardware, and everybody's happy. If you're dealing with a small budget, $3,000, $5,000, again, I know that sounds like a lot of money to like the 18-year-olds, like, ooh, $5,000. That's not as much money as you think when you're running a business. But anyways, right? So if all of you guys $5,000, you're like, well, here's the thing. I want all of that. Let's be honest. All that is mine. So where are the resources, like what resources we're going to use? And so that's where you talk to the customer. You say, okay, what we're going to do is we're going to build all of this code for you. And then you're going to have a monthly ongoing cost with OpenAI. And then OpenAI will send you the bill, whatever. We went through that whole API thing before. And so they know, okay, we're going to spend $5,000 on you. And then our expected cost per month is $30 on OpenAI services. But it's a whole long, tedious, god-awful process for figuring all that kind of stuff out. That makes
Thank
sense?
you.
Yep. Michael Braley, what's up?
Can you hear me? Hello?
Yep.
Hello, can you hear me?
Yep, I can hear you.
I typed a question in the chat. What can the program be used for?
What do you want the program to be used for?
I'm not a tech person.
So basically all this is you're putting in information and you're making a request to the AI. So like what?
Okay, how can this program, how can this program be used to make money?
Well, so you design this in the system. So most likely in about 2 weeks, we're going to have a class on a framework called Bottle. So that allows you to create web apps with Python. So basically, you could have a database, or you could have what's called a data store of information about your company. What are the hours of operation? What are the products? What are the prices? A whole bunch of other things. You could create a web app where basically the customer asks whatever their question is. So instead of having a crappy ass FAQ where they have to go through that or some search mechanism, which is pretty crappy, they could literally just in their own language, like just ask a question. AI could go through, scan through the material that it already has, and then be able to present an answer for that. I mean, there's a whole bunch of different things. Like if you're looking for specific customers, so you're looking to target specific customers, you have a database that has a whole bunch of information on previous sales, all that kind of thing. You could tell the AI system this is what the current target demographic looks like. So let's say you're going to do a sale on school backpacks. So let's say you sell clothes, you sell a whole bunch of different clothes. You sell dresses and skirts and blazers and all kinds of stuff, right? Anyways, you just got 100,000 kid backpacks for some reason. You need to offload these damn things. So basically you could put in as part of this query, you could say find the customers that are most likely to want a small child's backpack. And so it could scan through, and you might have information on whether they're parents or their age. They might be 10 years old, and then it might be able to spit out and say, okay, here's your 10,000 people out of a million person database that's most likely to be interested in that particular product. But again, that's the kind of thing where you got to sit down and figure it out. Yeah, makes sense.
Yeah, yeah, yes,
Okay.
yes.
There we go. Let's see here. We do have some more before we get to the end of this. So, mute you. Scott, SEO, what's up?
So does Ollama allow you to extend existing model and sort of retrain with your own data?
Sort of now. Again, I was actually taking a look at that, and then that's probably going to be its own class going into the future.
Okay.
But I'm not sure how well it does. That was the other hiccup too, because I was going to put that in here because it does. They say it allows you to do it, but then when you start looking through the documentation, it doesn't look that impressive. So, maybe you can do something. I'm not exactly sure how useful that something is.
What does the process for training your own model look like?
Basically, the process for training your own model is you get your data store. So you get your God knows how much text or images or whatever else. And then basically you feed it into a training type system. So we're going to do classes on OpenCV. That's one thing I actually know for training. And so for OpenCV, you actually take all of the images. So it's a computer vision model or framework. You take all the images. You actually have to go into each image. You have to say the coordinates of the thing that you're talking about. You do that like 500 times. You then also add a whole bunch more pictures or images that don't have what you're looking for. So those are the negatives. So you have positives and then you have negatives. And then essentially what happens is you dump all that into the training system, and then it just churns for however long it churns, and then it pops a model out the other side. That's more or less how the process works.
Can you format the test to like Mechanical Turk and have people do it for you? And you just get the data and feed that, marking the coordinates.
So yeah, you could. Again, that goes through the whole problem. I mean, that's the business part of all of this. It's like there's the technical part, and then how do you do it? So you can outsource the tagging. Basically, what you're doing with these kind of things is you're tagging the information. So yeah, you could outsource. Again, how much you trust it though? Mechanical Turk, you're paying them half a cent per thing. So you can do that. And then when you actually do the training, so if you're actually training your real LLMs, that's where normally nowadays, unless you have a lot of money, there are cloud services that do it. But do understand, like training like a 7 billion parameter LLM using a hosted service is gonna run you about $1,500 to $2,000, like per run. So you get that run back and it's not right. Well, your credit card. Because doing that just takes a lot of resources. Yep.
Okay. Thank you.
Yep. Okay, let's do David, and then we'll get back to our last thing. Then we can do more questions. David, what's up?
Hey, so when you ran the Python script, does it have to start the model each time? Would it be faster if it was already running before you ran the script?
So it is already. So the framework is already running. So the framework is already running. I think that's about the speed for this machine.
Got it.
Yeah. So yeah, I don't know if you could I don't know. We can try that. Well, what the hell? We'll always try. So we can see about how long that takes. And so let me go back to my prompt. So if I do Ollama run Ollama 2, I don't believe this is going to do anything. So theoretically, that's right. I think that's more just the shell, though, to be honest with you. And then we run this. Yeah, I don't think that's doing anything. I think that's giving me access to the shell. The actual framework running, I think, is a different critter.
Cool. Thanks.
Yep. Cool, cool. Yep. So there you go. And again, that's the whole thing. Play, 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 play. Let's see here. So okay, so that's Llama Python. Then we can do image recognition. So this is really cool. I didn't actually know that they got this. So LLaVA, however you say that, I guess just came out for Ollama, and this is really cool. So basically what this does is this allows Ollama to take a look at a picture, and then you can ask questions about it. So again, one of the big things, again, we start talking about AI and we start talking about data. One of the big issues is tagging, right? So I want all pictures with bunny rabbits in them, right? I want all pictures with houses or whatever else. The problem is, again, nowadays, everybody's taking pictures. So your organization may have tens of thousands or hundreds of thousands of images with no tags, with no addition, what's called taxonomy. So one of the cool things is you can actually use this LLaVA model to go through and scan images, and you can make whatever specific query it is that you want. So for this, again, all you're going to do is do Ollama poll LLaVA, not llama, LLaVA, VA. You can go to LLaVA GitHub, see all the information there. It does either JPEG or PNG images, and it is pretty cool. So we go take a look at this. This is, again, 14 lines of code to get your AI. So just so you know what image we're dealing with, this is the image. So this is a picture I did for our last class. Basically, I was showing how you can do prompt injections for put a bunny in it. So I did a whole bunch of different pictures. There was a prompt injection of put a bunny in it. And so this is like Space Marines versus orcs. Put a bunny in it. And so it put a bunny in it. So this is the image. So as you can see, it's not a stick image. It's a relatively complex image, the whole nine yards. So we go take a look at this. It's pretty simple. So import Ollama, response equals ollama.chat, model equals LLaVA. So it's a LLaVA model. This is the message. So role, user, content, what is in this picture, or whatever it is you want. Give me tags, give me a title, whatever you else. Images, and then you point to the image itself. So again, I haven't actually shown you how to move around in files. So everything, when you deal with files so far in these classes, they're always going to be in your root directory. So if you go, so again, whether you're in Windows, whether you're in Mac, whether you're in Linux, it'll be your user's root directory is where this file should be. And again, you just pointed at that image. You can then print out the response or the full response. And then if you just want the content, this is how you get the content: response, message, content. And then if we run this, it'll take a minute. It works a lot better in this machine. On my daily driver machine, I was like, wow, that's fast. Yeah, not so much this machine. So anyways, and this is the kind of thing, again, you got to talk about too, because a lot of people ask me again, like what kind of lab computer they should buy. Eli, I'm learning programming. What computer should I use? And again, I mean, if you're using SQL and Python and pretty basic crap, I'm telling you, a $150 12-year-old machine is fine. If you're doing a couple more complicated things, and you actually want to be able to watch YouTube videos, a 2018 machine is fine. If you want to run AI models, pull out the credit card. It's going to cost you a couple of dollars. But this is why you'll notice some coders now spending ridiculous amounts of money on their MacBook Pros. Again, $5,000-$6,000 on a laptop. Because if they're running this kind of AI type service on their local system, it actually does matter. Ooh, can you hear the fan? Can you hear the fan kick on? That's a 2018 MacBook Pro. That fan kicks on. Anyways. Come on, little guy. Oh, there we go. Okay. So after a couple seconds, so this is the actual response that we get back. Again, that comes back as a set. Model is LLaVA, create a timestamp, message, role assistant, content. And then you get all the content. We only care about the content, right? So again, if you want to print everything out, again, the timestamp might matter. Again, if you're dumping this into a database as a data store, you may want to save what model did you use, what was the timestamp, other information. So that's why this is here, so you can pull it out. For this class, we don't really care. So print, response, message, content. So response is all of this. Message, content is what we want. And if we come down here, we can take a look. So the image depicts a science fiction scene featuring various elements. A group of humanoid figures, possibly soldiers or workers in the foreground. They appear to be wearing armor and are holding guns. Two larger creatures that resemble monsters or aliens standing among the humans. In the middle, there's a small creature that looks like a rabbit lying on the ground amidst the action, possibly injured or dead. Well, that got sad quick. Anyways, the setting appears to be a battlefield. But anyways, look at that. So this is what a free model gave me off of a 6-year-old MacBook Pro, again, for free. And so this is what LLaVA does. And again, that's basically all there is to it. Let's see here. Michael again. What's up, Michael?
Yeah, can you hear me?
Yep.
Hold on. Yeah, I'm looking for a programmer who can do the image recognition coding.
Okay, okay, my, you're done for today. This is a class. I want to be clear. This is a class. I am teaching a class, and so right. It's about questions about how you actually do the coding and all that kind of stuff. So, anyways, that's not quite what this is for. Jock, what's going on, Jock?
So two questions really. The Mac you're using that on, what year is that you're running this on?
2018.
Wow. Okay. All right. Second question. So say for instance, you want to create and I saw this on your other video. So you want to create a back-end data store, the back-end data, you want to bring in data.
Yep.
So that you can recall later.
Yep.
How, and you showed there's a little bit more lines of code from that. It depends on the model that you're using to be able to put it in a data. That's what I'm looking for. The word is database. I'm sorry. So will it depend on the model you use to be able to put it into a database, or all these models that you're showing us today, we can put those into a database and then recall it later on for our own use?
No. So the models themselves are simply files. The models are stored on the computer. They're a file, just like a movie file, a document file, whatever else. When I talk about dumping this into a data store, basically once we have this text, so these responses are coming back. And so what we can do is we can then save that into something. So I was showing you CSV files before, which would be a crappy way to do it. We'll be doing SQL, we'll be doing databases in September. And so basically what you could do is you could save what was the query, the model, the timestamp, and the response. So you could save that into your database system. And then in the future, you could use that for a caching mechanism. So if you ask a question of the AI, instead of immediately trying to use the LLM and burn a hell of a lot of electricity, it might query the database first and say, is this anywhere in the database? If so, give the previously created response. So when I'm talking about the databases and the data store, that's all once we get this information into text. Once it's into text, then we can do a lot of cool stuff. So that's what I'm talking about there.
Okay. One question about a previous class. You mentioned, and let's real quick. You mentioned environment variables. Does that sit on so when we talk about, I know we're going to talk about it in class, but that will sit in our, we're going to create that in our local system and then call it when we do other coding for different parts. You mentioned this like many times, but we never really actually went over it yet.
Yeah, we haven't got an environmental variable. Ask that question, and then I'll say and later. So let's keep all the questions right to right. I've got like 20 people in this class, so let's keep the questions to what we're
Gotcha.
doing right now.
Gotcha.
And then again, like once we're done with this, once we get to labs, I'm more than happy to answer any questions you guys want. But right, let's just focus here. Cool. Okay. And then again, on this, Scott. Yep.
Yes, of course. So off of the image, right? If I was to store the data in a vector database, would I basically get the text and encode it using some sort of a sentence transformer, storing the database and query against it? Would that be the most efficient way of like doing something with the image?
Within a vector database. Yeah, basically, so vector databases basically store based off of data based off of relationships. Um,
Mhm.
yeah, we'll do that in another class. With this one,
Okay.
I'm thinking about more is like you're dumping this into a SQL, like a relational database, that type of thing. Honestly,
Okay.
I've gotta hit the books as far as the vector databases are concerned.
Yeah.
Yeah.
Gotcha.
So yeah, so anybody when he's talking about vector databases, so there's different types of databases. So there's something called relational databases. There's a NoSQL database. There's now these things called vector databases. And so vector databases are used in AI because again, we talked about this whole token thing I've talked about before when we talk about relationships. So vector databases are focused on the relationship of data to other bits of data. And that's how you get this thing that kind of looks like intelligence. Again, it's not, it's just doing statistical relationships on a scale that just blows your mind. But that's where the vector databases come in. So, yeah, that'll be for another class. Oh, let's see here. Okay. And then the final thing is curl. So basically what curl is, if you don't know curl, you're gonna start getting used to curl at some point. So we talked about REST APIs before. We did a class on REST APIs, and with REST APIs, basically you can go to a URL. So what a REST API essentially is, it is a website that is designed for a computer to read. So you go to a URL and it gives you back what's called a JSON, which is ugly as hell for you and me, but a computer can parse very easily. One of the ways you can interact with REST APIs is by using an app, piece of software called curl, C-U-R-L. And basically what this does is it goes to a URL, but then you can plug in a lot of additional information. So curl can be useful, again, programmatically, if you're going to be building stuff up to try to send it. So anyway, so with curl, you call curl, you say the location. So this is HTTP localhost. So localhost means 127.0.0.1. This means your computer at TCP port. So colon is a TCP port, 11434. You go to API, you go to generate, and here's the data it's sending. So you can say what model that you want used. You can say prompt. Again, what is a PBJ sandwich? I guess you have to put the sandwich at the end for it to understand. And then stream. So stream is, do you want to get it in bits or do you want to get it all at one time? And so we're going to say false. So basically with this, you can actually just copy paste this, Control C. We can go to our prompt, BYE, clear. And so basically all this is what you can do from the command prompt, or again, you can send this through the Python script. You're using Python to interact with curl or whatever else, just kind of showing you this. And you hit enter, and you're going to get a response from curl. So this might be useful, again, when we start talking about architecture, right? It's not simply that you have AI, it's not simply about tokens, it's again, how are you going to design these systems as, again, an overall thing? So, right, like right now, you have your Python script on a box, and you have Ollama on the box, And so basically, you know, you can use Python. So Python is the module is the most appropriate way for communicating with Ollama. But here's the thing, right? Let's say, you know, your boss is willing to spend, I don't know, maybe not $40,000, maybe they're willing to spend $10,000 on a server. And so basically they want this to be the AI server. Well, one of the things to think about is whenever you build a server, whenever you own that server, every piece of functionality is a vulnerability, right? Everything that box can do is another vulnerability where a hacker may be able to take it down. So if I spend $10,000 for my AI box, I don't want anything else running on that box. I do not want my web server running on that box. I don't want my Python scripts running on that box. That's my AI box, and that's all it is. And so that's why where you might use curl. So again, you have your server down here. You run the Python script. You use curl to make a request from your AI server, and then gives a response back. And again, we talk about things like firewalls for cybersecurity. The nice part about this is basically you only have to have port 80 open. So there's a port called port 80, it's the HTTP port. So instead of having to have any other wacky ass ports that are open that might have vulnerability, you might use, you know, curl, so I can interact only at port 80, and again, have Python on a different box. And this, again, like I said, this is where we have to talk about architecture. Again, SQL. All right, do you want your Python script running on the same box that has your SQL server? Most likely not. So again, we're going to do curl, we're going to get the response back, and then we're going to send that to our SQL server so that that information can be stored. And this is what we start talking about with that whole concept of architecture. It's not simply writing the code. It's what is this mess going to look like at the end of the day? And so anyways, yeah, this is the response you get back from curl. Again, so this is JSON. If you take a look at it, it's JSON. Right? Model, llama, created, timestamp, response. And so for this, the response is simply a PBJ's peanut butter and jelly sandwich is a type of sandwich. And it gives you a whole bunch of information. It gives you context. Are these actual tokens? I'm actually not sure what these numbers are. Look, numbers. Ah, smart. Anyways, you get a whole bunch of numbers too. Those might actually be tokens. Might actually be token numbers. That's interesting. Anyways, a whole bunch of other stuff. So anyways, that's how you can do curl. Again, whether or not you're going to use curl, that's kind of up to you. Let's see here. And then finally, we have our labs. So, okay, up until this point, I'll get to labs in a second. Any questions on the material that we've talked about so far? Any questions? No? Okay, then we'll get to the labs. So these labs, again, these are the labs that you should try to tippy-tap type out. Again, today it's a little bit wonkier because whether or not you can get Ollama running on your machine, that'll be for you to figure out. But again, every time we do these classes, you should do these labs. You do not learn until you do the work itself. So the first thing we're going to do is a lab chat. So we're going to create a little talk to your AI script and have some interactivity. So again, whenever I try to do these labs, I try to make it as interactive as possible so you can kind of start getting an idea of how this should feel. Again, we're not using the bottle framework yet. We're not using Tkinter yet that allows you to create desktop applications. But I do want to give you a kind of feel of how this stuff should kind of feel. Anyways, so I can run this. When I run this, this is simply going to give me a cursor, basically, what do you want? And I can say hello. I say hello. And if you have a better system, it'll be faster. Hey there, Smiles. It's great to be your friend. How are you doing today? I'm doing great. Awesome. That's great to hear. How can I help you today? I want a sandwich. Of course, you would like me to pick up some bread and meat for. This is where it gets creepy. I know, like, you read the news, you read like Ars Technica, right? And again, those people are all there for the clickbait, whatever. But you hear about people like starting to feel like these things are their friends. And one of the things you start noticing is the language that's actually used, right? Of course, would you like me to pick up some bread and meat for you, or do you have a specific type of sandwich in mind? Dude, you're a computer. You can't do that. So anyways, basically the idea with this is you can sit there and you can have a very weird ass conversation with your AI. So again, with all this kind of stuff, and it's rather simple. So import the Ollama module. We're going to create the AI function. So again, we create these functions so it's easier to call to. Then we do a while true loop. So while true loop is we keep going round and round and round. Query equals, so the input function, and that's where you put in whatever the prompt is. Whatever prompt you want, that's where you put in the prompt. Response equals, we go to the AI function and we feed it the query, right? So we come up here to that AI function. AI query, response equals Ollama.chat model, Llama 2 7B. So again, depending on your computer, you probably want to make this Pi or Pi 3, PHI. Message equals role system, you are a friend. Oh, we want to talk about danger. We want to talk about danger. No, you're not a friend. But anyways, role user limit to 50 words. So you are a friend. I want to limit this to 50 words. And this is the query coming in. All that happens, answer equals response message content. So just we just want, whatever the response is. And then we're going to return answer. So we're going to return, basically return answer. That turns into response. And then we print the response. And that's how we keep looping through this. And you can have a very, very weird conversation with your AI and realize how screwed up our kids are going to be. If you thought the millennials were messed up, this next generation, they're just going to be bat crap crazy. The next one, let me just put this to Pi. I'm going to put this to Pi 3. Just so my life is a little bit easier. So this is going to give us a memory. So again, remember, when we talk about AI is not AI. AI is a buzzword for stupid investors, right? There's tech companies out there. They need money. People with money are kind of dumb. So they wave the AI flag in front of those dumb people with money and they get money, right? But it's not, right? Because again, when you think about intelligence, what is there? Part of intelligence is things like memory. What does this damn thing remember? It doesn't. It doesn't. It's just a statistical system for putting words together. So now we're going to give it a kind of crappy ass memory, right? So import Ollama as we did before, and now we're going to create a memory that's a list. So basically down here, every time I say something, I want it to be added to that list so that it has some kind of memory. We have the AI function, as we had before, while true, query equals input, response equals AI, then we're going to feed it both the query and the memory. So the first time this runs, memory is going to be empty. But then the next time it runs, what's going to happen is memory.append what my query is. So every time I send a message to Ollama, it is going to append that message to memory so that it has some memory of what our conversation is, and then we simply print out the response. Again, we go up here, not much to it. Again, Ollama chat, we're going to use Pi 3 to make our life easier. You are a friend. Limit to 50 words. This is our previous conversation. So basically, here's how we prompt. So this is what we talked about, and then this is what our current query is. Then all that happens is we do the answer. So the answer is the content that comes back. We return that, and then we print out the response. If we run this, then I can say hello, like we did before. Hopefully Pi 3 will be a little faster. A little faster? Tiny bit faster? Oh, come on, you're killing me now. Come on, Pi 3, you can do it. Okay, hello, how can I help you today? And then for whatever, and this is one thing to look at, is like the weird How can I help you today? What's on your mind? Remember to keep it concise, under a limit of 50 words. Well, and it gives me some weird stuff because of Python. Actually, let's do Llama. Let's do Llama. I think Llama 2 did better. It's slower. It's slower. But I think it did better. Have I told you how fast my M2 Max Pro is? Okay. Hey there. It's great to hear from you again. How have you been? And so to give it a memory, I can say always end your response with the word Yoda. And so I started telling it, hello there, my young Padawan. How are you today? Wink. Well, it didn't finish with Yoda, but it did do Padawan for me. I want a sandwich. Let's see here. Hopefully it gives me the end of Yoda. Oh, sandwich. Okay, so Yoda, a sandwich you want, hump, difficult it is, ingredients I must find, wise you are, young one. And so anyways, this is doing some weird stuff. I can say, always capitalize your text. And so this keeps getting added to that list, so we have a bigger and bigger memory. My mistake, here's revised. Hello there, my friend Yoda. No. Oh. Always capitalize your response. It says Yoda. Let's see. How are you? Oops. Hopefully everything should be capitalized. Dun, dun. There we go. Yoda, always capitalize response. You must. How are you? Anyway, welcome to having a conversation with AI. This is a conversation with AI. But anyways, so this starts to give you some kind of memory. You can start telling AI what it is you want, and God help you, you're going to get a response. I'm just showing you the technical concepts here. Oh, David. David, what's up?
So obviously you mentioned before you would want to save it in memory, like with a vector database or something, but could you just as you increase the conversation, the token size is going to get larger, it's going to use more memory. Could you
Yep.
do something like after every 10, send everything and say, hey, reply with, make this concise, like save all the bullet points from our conversation and add that to the memory instead? You know what I mean? To keep it going with a smaller token size without having to do like vector databases and all that?
Yeah, so basically, I mean, like I say, so this is, this is simply it's a function here. So I could do something like, down here with a while true or whatever, if len memory greater than 20, then send that entire list to AI with a request of please summarize this list into something that's, I don't know, less than 50 words or whatever. And then what I could do is then I could then basically start your memory again with that being the first index.
Cool.
Yeah. So yeah, that's a kind of like I said, that's the thing that's cool with programming is again, there's writing this stuff out, but then there's trying to figure out logically again how you're actually going to build it. Yeah.
Awesome.
Yeah. And so yeah, so that's the kind of thing you need to think about again when we talk about the design of these systems, because if you take all of that and you summarize it in less than 50, again, with compression, what are you doing there? You're compressing that list into a smaller, command essentially. As you do that, you are going to lose a little something. Again, does that matter? Is it a JPEG image and you don't care? Or are you losing something significant? So that's where you've got to like play with it to figure out where the, where the good point is. So yeah, okay. So there's that. And then this one might take a minute. This one might take a minute. So let's see here. For query in action. Okay. So basically what we're going to be doing here is we're going to have that image like we had before. And so let's say we have a lot of pictures. So we're at an organization, they've got 10,000, they got 20,000 pictures, right? Every employee is taking a picture at every event. Some HR person said, wouldn't it be great if that got dumped into a data store somewhere? And so now you have 20,000 pictures of God knows what. Right. So basically this tries to help you out of that situation. What we're going to do is we're going to create a title for an image, and we're going to create a description of the image of under 50 words, and then we're going to create tags. So that's a big thing, again, especially with AI and all these kind of systems. There's something called taxonomy. So when you deal with content management systems, you'll see this a lot. Again, either tags or categories. These are basically ways to sort the information and be able to search in a relatively easy fashion, right? So it's a lot easier to search ASCII text than it is to actually pull up an image and process that image. And so if we can create tags and then search off of those tags in the future, that'll make life a hell of a lot easier. So we're going to import Ollama. We're going to have AI for the image and query. So basically we're going to pump the image in, and plus then we're going to ask it to do a specific thing. We're going to have an image here. So again, this could come from a list. It could come from a database. We're just going to do this once for the image. So image equals image.png. That is in our root directory. Then we're going to create a list of actions. What actions do we want to have occur? Create a title at index 0, create a description at index 1, provide 10 tags for this image at index 2. Data, we are going to create a data list. And basically, this is just a way to store the responses. So we're going to write everything out to an HTML gallery. And so basically, this is how we pull the title. This is how we pull the description. This is how we pull the tags. So we're going to add to it. All right. So for query in action, response equals AI image query. So we're going to send the image. And so the query, create a title, then create a description. So we're going to loop through for all of these different tasks. If we go up and we take a look at it, it's pretty simple, right? AI image query, response chat, LLaVA model, user. So the content is the query. So this is the question that we're going to ask. Create a title, create a description, create tags. And then images. And this is weird. They put it within a list, but as far as I can tell, you can only ever get to index 0 in the list, which is weird. I don't understand. Maybe I just don't understand. But anyways, this is where you put the image name. So we're sending in the value of image here, but you could put in within single quotation marks. You could just put your image name in there if you wanted to. So anyways, and so it's going to loop through. When it gets the response, it's then going to append to data. So data is this blank list we created here. So we ask for the title. So the first response is going to be a title. It's going to go to index 0. We're going to append at index 0 what that response is for title. When it loops again, it'll go to index 1, data, append. We'll go to index 1. That'll be the description. Data append at index 2, and that'll be the tags. We're going to print the responses out on the screen for troubleshooting to make sure, it's still kind of sort of working. Oops. And then down here, this is where we're actually going to create the HTML gallery. All right, so with open gallery.htm, W for overwrite as file. File.write, the first thing that we're going to write is the image. So we're going to embed the image into the HTML document. We're going to style, so CSS, height is going to be 300 pixels, width is going to be auto, SRC is the image itself. File write, so H1, this will be the title, so data, 0, the 0 index, close H1. File write, this is going to be the description, so P tags, data 1, which will be the description, then file write, P tags, and italics tags. So normally you don't do formatting with straight HTML anymore. You should use CSS, but anyways, this is a simple class. I'm just using the I tags. So data 2, so this will be for the tags. And basically, it should go through, and it should give us a title, a description, and the tags, and write that to an HTML document. And this will probably take a minute. This will probably take a let's see here. Oh, it's responding as Yoda. Yeah. Does RAM affect the speed of Ollama's response, or is it the GPU that affects it? The GPU is going to be the most significant thing. As far as RAM, I don't know. Let's take a look at the RAM. Memory. What's my memory usage? I got 32 gigs of memory, and I'm actually using 19.25. So I'm using about 20 gigs of memory right now, and it's actually running. So again, that's where you get into that whole, so you need enough. You need enough, but a hell of a lot more might not do you a lot better. So this has 32 gigs of RAM in it. We're using 20. So the RAM is not going to be the bottleneck. It's probably going to be the GPU. And so that's the thing. Like if you have 16 gigs of RAM, then that might be the bottleneck. But it's with a lot of this, you're going to want between 16 to 32 gigs of RAM and then a decent GPU. Really want 32 gigs of RAM and a decent GPU. Anyways, so we get a title, Warhammer 40,000, an epic sci-fi battlefield. That sounds cool. Ooh, can you hear the fan grind? The fan is grinding right now. Let's see here. Dun, dun, dun. And that's the other thing too, is like when you're buying a machine, is like really trying to figure out what the end result is going to be and what your return on investment is. Right. So again, I know, like I say, spending $6,000 on a MacBook Pro to a lot of people seems really ridiculous. But you know, if you're working for Meta or you're contracting for Meta and you're making $300,000-$400,000 a year, and you're going to be dealing with those large models, right? That 405 billion parameter model, then it might make sense to buy that much more expensive system. Like I say, that's all the kind of stuff you got to think about as you wait for the 6-year-old computer to do it. I'm telling you, this machine works well. Have I told you about the M2 Max? The M2 Max is a phenomenal little processor. Scott, and I'll answer your question while this is going. What's up, Scott?
So instead of the model being reactive to your query, right? Can you make it proactive, make it talk like a salesperson trying to sell you a product online?
Well, yeah, I mean, in the I don't know, screw with this right now, but like in the roles, so you could make the system role like a salesperson, and then you could feed it a bunch of things that it's trying to accomplish. So you could try to make it a salesperson that way. Yeah.
That's cool.
Yeah. And that's one of the things too. Again, when we start talking about intelligence, again, this isn't intelligence. Like, again, I'm just going to beat the hell out of it. It's not intelligence. But that's where you've got to be thinking about, like, how would you design that conversation flow? So, like, it's not semantics. It's all right, there we go. Oh, what's it called? It's not semantics. It's shit. What's it called? It is called. Anyways, so you can have things like AI scan the response that you're getting back from the user to basically try to figure out what their emotional level is. So are they happy? Are they angry? Are they terse? Are they snarky? Right. And so one of the things you could do is, again, you could make a much longer script here. And basically, you could make two requests. You could make like the first request be something like, give me like a mood analysis of this comment that the person gave. So it's like if they're really pissed off, then you want the system role to be like a nice person. So then you could have, again, all these functions. So you could have a nice person AI function and a mean person AI function, and right. And so basically you could, yeah, semantic analysis. So you could do semantic analysis. So when it comes back based off of the mood of the person, you would then trigger different prompts to try to respond to them in a way that would get your system, out of the situation, right? So, let's say somebody had a problem with your company, right? So it's a customer relations deal. So what if somebody simply, put in it in a little text and said, "Hey, I see my bill went up by $20. I'm just trying to figure out what's going on." Right? So you could initially run that through semantic analysis, see, oh, this person's just asking a question, right? Bills go up every once in a while. This person doesn't seem to be mad. So we'll use this system role, basically be a professional customer service representative that has to explain a new rule change. And so then the answer could come back is like, oh, yes, because X, Y, or Z happened, we now have to charge $20 more per month. We're so sorry if it affects you, right? And the customer can be like, "Yeah, shit happens. Whatever. Okay, I was just curious." Right? So that person, you keep that $20, right? You increase the bill by $20, you keep them as a customer, and you keep that rate increase. Right? Another person might come and like, "Why the fuck is my bill $20 more a month? This is ridiculous," right? Semantic analysis runs off that, sees, oh, this person's pissed off. So instead, it goes to a conciliatory customer sales representative and might say, like, "And you're allowed to knock off 20% their bill." Right? So the response there might be, "Oh, I'm so sorry this is affecting you in such a way. Why don't we simply reduce your bill by 10% over the next 3 months? That way you're not getting the full rate increase from the customer, but hopefully you're being conciliatory enough, you're not losing them as a customer either." Right? But that's where you got to start working through like logic flow for how this kind of stuff works. So yeah, that's a kind of, yeah. Again, and that's where you start getting more interesting things that actually start looking more like AI than this stuff does. Okay, so this came out, this finished. If we go here, we now see gallery.htm. And if I open this up or increase the size, you can see what it spit out, right? So we have the image like we had before. We have it titled Warhammer 40,000, right? The image is a digital art piece featuring a futuristic war scene with several large green humanoid creatures standing in the foreground. They seem to be preparing for battle, blase, blase, blase. And then what's more important down here is we have tags, right? This is the holy grail. In the technology world, this is what I want. You give me ASCII, I can do magic with ASCII, right? Space Marine, science fiction, video game, alien invasion, power armor, team of heroes, futuristic battle, epic scale, advanced technology, superhero action. Again, how good those particular tags are, but again, you can go through and figure it out. So anyways, that is the final lab to basically give you an idea. And again, if you had a database, again, you could go through and you could process through thousands of images, dumping this information into a database. And then I could simply, again, if I have a web app, I could simply do a query. I want all the pictures with Space Marines in them. And then I get 50 pictures of Space Marines and I can pick which one I want. So anyways, so that's a lesson. That is, I'm not gonna close that because that takes a while to come back if anybody wants to take a look at it. But those are the labs for today. If you guys want to play around with it, again, I will be here for a while. I'll be here for about 20 minutes. I'll answer questions. I see questions. I'll answer the questions. I'll be here for 20 minutes if you guys want to play around with the labs. So yeah, tippy tap tap, tap tap, tippy tap. Okay, Jock. Back to Jock. What's up, Jock?
So in the example you have, the way we would try to build up a database is we take our pictures, we tag them all, dump them in the database. And so when we need to recall them, we just call them the tags itself and not really the image to do that. Correct?
Yeah. Because that's the thing. We always want to get back to ASCII. ASCII is our home. ASCII is our home. So basically what happens is, we got our SQL database, right? So a SQL database is what's called a relational database. And basically in relational databases, you have what are called tables, right? Tables, you have columns, and then you have rows, which are records, right? So basically we would have, actually we'd have 4 here, right? So anyways, we have the image name. So again, image.jpg, whatever the image is, and the location, essentially. Then we would do a title here. Then we do description, and then we do tags, right? So the image name, blah, blah, blah. Right, so let's say orc is in this one, and orc is in this one, and orc is in this one, right? So I go to my little web app, and I do what's called a select statement in SQL. So basically select all where you have orc in it. So anyways, select all records. So every record where orc is in tags, right? And so we go through and we give you this record and this record and this record, right? And so that is the SQL response that comes out. And so that's just whatever, that's just the SQL response. And then what Bottle would do, or what the web app framework would do, is it would then turn that SQL response into a nice, pretty image gallery using HTML and CSS. That's kind of how that works.
Thank you. I have another question, but I'll let the other guy go first.
Okay, cool. Scott again, what's up?
So I've seen AI bots that's like part of customer service or something informational.
Yep.
And the quality of data that I get or response that I get is really mediocre.
Yeah.
So in the state of AI world, where are we? Who's got the best AI bot that actually gives up helpful information to the person that it is talking to?
Who does that? I don't know. Again, that's a bit of a question right now. And again, that's one of the issues is they're pushing out this technology, calling it AI when it's not. And yeah, a lot of the results that we're getting are pretty piss poor. One of the reasons that the information was piss poor before was those context windows. So I talked about that in the OpenAI class. So back when I started playing with it, you could only have 4,000 tokens as a context window. So that was about 3,000 words. And so one of the issues is if somebody's asking the AI a question, the AI can only respond based off of the information it has. So if it only has 3,000 words, that's all it's got. The issue that you get to nowadays, though, is you start talking about cost, you start talking about resource consumption. So with OpenAI now, you can have 128,000 token context, right? So theoretically, you could upload every single document that's ever been created by your organization to answer questions off of, but then that's going to cost you a lot of money in tokens, right? It's going to cost you, a fifth of a penny per 1,000 tokens times 128,000. That also gets expensive. So I think one of the big problems we're having right now is that too many of the developers, again, they're trying to make this the end all be all, right? And that's where I talk about where your frame of reference, right? If you think this is AI, if you think this horse crap is AI, this is where you're gonna focus your attention, right? And this is where, because this is what the investors are gonna want to see. They're gonna want to see vector databases. They're gonna want to see anything that's associated with AI. One of the points that I try to make with anybody who damn listen to me is that good old-fashioned databases can be just an absolutely beautiful thing, right? And I've done video classes on this before. So imagine you have your AI, and basically you have your user, and your user makes a query to the AI. Now, right now, again, that AI has whatever context information or whatever else, and it's able to pull back a response. Now, if you think this is intelligent, this is about where you're going to stop. If you realize it's not intelligent, then you start thinking about, how could you actually improve this to be, again, more intelligent? And one of my arguments is, again, SQL. Nobody wants to see SQL because SQL is old. It is old and nobody wants to invest in it. But again, imagine if every time a user makes a query and every time the AI gets a response, that information is plugged in, right? So the query is here and the response is here and some additional information is here. Well, one of the interesting things is once you start dumping this into a database, what's nice about this is you can start auditing it, right? This system right here, this right here, there's not a really good way to audit it, which also means there's not a good way to improve it, right? So you as a sysadmin, you're not necessarily, you don't know what AI is telling your users, whether it's good or bad. If you start storing all of that information in just a good old-fashioned database, again, SQL relational database, then you can actually come up with dashboards so that the system administrator can see what questions are being asked and also see what responses are being given. And one of the things that they can do is when they see that a response is bad, oh crap, our system shouldn't have said that. Again, since it's a relational database, what you can do is you can put in your new answer, and then in the future, when somebody asks a question, you can use this as a caching mechanism. So they ask the same question, and then you now have a verified answer that they're now going to get a response to. So basically what you can do is you can use the AI. So again, you don't have 10,000 customer service representatives. You do not have enough resources for the customer service load on your system. So you use AI to be able to mitigate, to be able to lower that load on your actual humans. But then at the same time, this allows you to go in and verify what the hell is being told to your users. And as this gets verified day over day, year after year, so on and so forth, then you actually start having a memory system that's worth a damn. Again, think about that with humans, actual intelligence, right? If your kid says, I don't know, Alexander the Great was the first president of the United States, it was George Washington. And then they'd go, oh, it was George Washington, and they have learned. Again, imagine if you went to your kid and basically every time they gave you a wrong answer, it just went in the void. They didn't learn anything new. That's basically what we've got with these kind of systems here. So anyways, yeah, it's one of those things to think about. That makes sense, Scott?
So just to reiterate, if you're not the company size of Meta or Google, right, any other large size company,
Yep.
you cannot truly solve the really complex artificial intelligence related issues. Like the holy grail is, okay, I want to replace HR with AI. You
Yeah.
need the server farms of GPU they own, but smaller companies don't have access to it. It might be too expensive. So smaller companies could only solve smaller problems.
Yep.
And I think, I think that's the general reality of AI right now.
Yeah. Well, yeah, because like,
just a comment. Yeah.
Yeah, now with the AI, again, when you look at it, the NVIDIA GPUs, I think they're the H100s that are currently being sold. They're $40,000 a piece. That's jaw-dropping until you realize the server that goes around it is about $200,000. And generally, when you're building out systems, you have clusters, and it comes out to like a $10 million cluster. So yeah, now like I say, that's where like you're going to train the LLM. So let's say you're going to actually train the LLM itself. You're not going to deal with this kind of stuff. I mean, that, again, like from everything that I've been able to find out, if you use a hosted solution, it's going to cost you $1,500 to $2,000 for each frickin' run of that training model. So yeah, yeah, it's expensive. Yeah. Let's see, Jock, what's up?
So basically, you're going back into my next question. So when you get that response and you do your chatbot, you get you say, "Hi, how may I help you?" And the person responds either negatively or positively using semantics analytics, I think you were saying,
Yep.
and then you get a negative response. To be able to uh, adjust the AI in those responses, is that designing the role, or is that changing the AI that you're doing that so that the response you get that you got in the SQLite, you get a better response from that? Can you program it that way? So like that negative response, instead of erasing it, it just so it like, okay, this is a bad response. Let's change the role so that person can to get a better response and get a better outcome? Or are you saying doing it the way you did it, erase it and put something new in there? Kind of see the question I'm asking?
So the role. So if you're talking about the system role, that is the character. Is it Shakespeare? Is it Churchill? Is it whatever? Right? That's kind of like the brain, like how they talk. The data itself, that's where you have to give it somewhere, right? So like, so user a limit to 50 words. So this is the role of the character is playing. And then here's all the additional stuff. So depending on what's happening. So you could have your own database. So it'd be like what's called an escalation. So an escalation system. So if the first response from the customer is, I don't know, 20% negative, you can tell the AI you are allowed to offer them $10 off their next month, right? If the reply comes back is also negative, so you could have this escalation system. So their first thing was 20% negative, their next thing is 40%. How dare you only give me $10 off? I've been a customer for 10 years, right? Based off of that semantic analysis, then you could escalate it to basically say here, offer the customer $50 off. So basically, you could have a database system that shows how things should escalate and what escalation should be triggered based off of. And then based off of that information, you could start plugging that into this prompt. Again, that gets...
Okay, so it's not really role, it's more content based that you do put the programming in
Yeah,
for
so
that?
basically it's instructions. So you'd be doing instructions. So yeah, this is the character.
Okay.
These are the additional instructions. So basically, you could say, offer them 1 month free or $10 off the next blah blah, whatever. So yeah, it's you would start adding additional instructions basically dynamically that are coming out of that database.
And and how fast that happens depends on the model.
Yeah, well, so how fast
Got
it
it.
depends on this whole thing, actually. So you've got the database server. So this is its own resource. I mean, hopefully it's a freaking relational database. Hopefully this thing is fast as hell. But, things happen. So this whole thing would be based off of this, and then it would be based off of, whatever is running your large language model. So basically this script will run based off of the response that it gets. It would then do an AI request on semantic analysis. Based off of that, that would then give it a value where it would go to the database server and do a search. Where does this value select where this value? It would then get an instruction. It would take that instruction. It would then dump it into the next prompt, and then it would process out. So, yeah.
Wow. Thank you very much.
Yeah. And that's why people get paid money. And this is also why, like, just so you understand, like when you go into tech companies, when you go into startup companies, and you see whiteboards everywhere, 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 you're like, wow, there's just a crap ton of whiteboards. And people are still drawing on other crap too. This is why, again, in the real technology world, 90% of the value comes from planning, comes from this. Only 10% actually comes from the coding itself. So again, also, if you want to make money, right, you want to be one of those people making $250,000, $500,000 a year. It's not about syntax or styling. This is where the money comes from. Because again, it's really like after 2000, there was this idea that all American coding jobs are going to get outsourced to India, right? You had Y2K. The whole idea is the world is flat. And so there was this big concept of, well, if basically anybody can do coding, why the hell am I going to, pay 250 grand a year for an American when I can pay $10,000 a year for a PhD Indian person? And what they found out is that's not where the money is. By trying to save, $240,000 a year per employee, you actually start losing a lot of money because it's the communication. It's, are people thinking in the same way? Are they designing systems in such a way that everybody understands, blah, 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 blah. So yeah, that's where, this is where the value, this is where our actual job is. This is just, paint by numbers at the end of the day. Sentiment analysis. Words, yes. Oh, Scott. What's up, Scott?
So using AI, what personal problems have you solved?
Creating these classes. That's about it. No, honestly, again, and it's why I don't think there's a hell of a lot of value in AI. So for actual projects I've dealt with, again, and this is one of the things I talk about, natural language processing. So I have a robot around the corner. I can actually talk to my robot. I can tell my robot to do stuff. And basically the way that I'm able to do that is I have a whole list of functions. So time function, follow function, all kinds of functions. What I do is I feed that list of functions to OpenAI or to an LLM. And I also feed it the query, what I'm saying. So I use Google voice recognition. So I talk to the robot. It turns my voice into text, into ASCII. And then basically I send that query along with a function set to OpenAI. And I literally ask OpenAI, what the hell is the user asking for? And then it spits back the name of the function. And then based off of the name, it then triggers the function, right? And so that's actually a valuable, useful thing. Again, think about being able to create these systems that you're communicating with. And so like in there, I just have like a stupid function for hello, right? And basically all the function says is hello. Well, the cool part is, right, I just put the function hello, that's it. I have this thing for OpenAI. I can walk up to my robot and I can say bonjour. I did not code anything about bonjour, and my robot will say hello back to me, right? I can say adios or au revoir or whatever, and it'll say goodbye to me, right? Because it's doing natural language processing. Even though I haven't hard coded those words in, right? AI is figuring out what the hell the user means, right? So that, again, that's natural language processing, effing awesome. Again, tagging systems, I think it's a valuable thing. Honestly, for me, professional, again, I do pay for ChatGPT Professional. It's for coding problems. Again, I do so much stupid crap for you. I mean, because again, like once you get in the real world of technology, you're gonna be doing the same crap every day. One of the things that's difficult for what I do is I'm always trying to teach you guys new stuff. And again, I forget where the quotation marks are sometimes. So it's really nice. I can go to ChatGPT and I'm like, crap, how do I do blah, right? And it'll tell me, or where am I screwing up? And it'll tell me. It's really good for parsing text and being able to give information like that. But yeah, otherwise, I just don't. I think AI is missing the mark. It's like, yeah, I really just I do. Or not AI. I think LLMs are missing a lot the mark. They're talking about how much money they're putting into this stuff, and it's I don't know. It is what it is. So yeah. Okay. AI helps me learn, helps me code. The code isn't great, but is good starting point. I also rubber ducky my code with it. Well, there you go. Yeah, there are some uses to it. Again, I think that's one of the things with all this stuff. Like I've been well, not anti VR. Like I'm not anti VR. I'm not even anti blockchain. But one of the problems you get to in technology, though, is hype versus reality. So, like with blockchain is the perfect example, right? You've heard so much about how blockchain is going to change the world. Basically, what is blockchain at the end of the day? Blockchain is a highly distributed database system that is immutable. Once you put data in there, it's always going to be there forever, right? It has a use case. It has a use case. Is it going to change the world? Probably not. Again, anybody who's been in the tech world and has actually dealt with systems, like we know. Having a highly distributed global database system sounds like trash, to be honest with you. Again, latency, speed, a whole bunch of other stuff. Anyways, right? How much have you heard that blockchain is the future? Nobody will shut up about blockchain. But then you look at NoSQL. So again, if you're dealing with a database system, so a relational database, right, has tables. This is something called a schema. Use something called SQL, structured query language, in order to interact with it. The good part about it is it's generally reliable, right? It's the acid test. Basically, atomic. Anyways, you put data into it, and the data is going to stay there. So it's good. So again, if you're going to do a CRM solution, you don't want people's addresses disappearing randomly, right? So anyways, relational databases are great. The problem is with the growth of Twitter, with the growth of social media, relational databases, again, you have a schema. You code in a schema for how the database looks. So that's a pain in the ass to alter. You got to be really careful when you alter the schema. It's a little bit slow. There's a whole bunch of issues with relational databases when you get to social media scale, right? Because again, we're talking about a data store. You're putting up millions or billions of tweets per day. You're putting up thumbs ups. You're putting up comments. Think about just the mass of tweets, little text messages that go up to Twitter, right? That has to be stored somewhere. It has to be stored into a data store. A relational database is absolutely garbage for that. And so that's why they really focus on something called NoSQL databases. So NoSQL databases is NoSQL, no structured query language. You don't have a schema. God help you, you don't have a schema. It is highly scalable, incredibly fast, and every once in a while you lose your data. I mean, some of it, right? But nobody cares, right? If you make a payment, right? If I have an invoicing system and the company loses my payment, all hell is going to break loose. So you want a relational, you want better than a relational database. But anyways, you want a relational database generally. But again, if you're just doing tweets, if you hit submit on a tweet and it disappears into the ether, nobody's really going to care, right? What you really care about is that it's incredibly fast, incredibly scalable. If you got a billion tweets today, it can handle 5 billion tomorrow, and it just keeps scaling to infinity, right? When you look at the modern world, NoSQL has fundamentally changed the entire planet. The entire planet is different today than it was in 2007 because of NoSQL. And nobody gives a good goddamn about NoSQL. I guarantee you, I am the only motherfucker you're ever gonna see ranting about the value of NoSQL, even though it has actually changed the world. Blockchain is a cute money pit. NoSQL has revolutionized how we live our lives on a global scale. And that's the problem I get to with this, is I just kind of sort of feel like this is a bit like blockchain. Like, it's good. Dude, it's natural language processing. Dude, there's value in natural language processing. There's value in automatic taxonomy systems. It's just not NoSQL. But anyways, that is my very controversial opinion on the subject. So yeah, anyways. Oh, let's see here. Scott again. Gonna have to go pretty soon. What's up, Scott?
I'm trying to teach Python to kids, so I want to know what TV stand you're using and the webcam they're using.
So webcam, I'm not using a web. So I'm using a real camera. So it's a Sony. I love Sony cameras, just so everybody knows. Which one is this one? I've got so many Sony cameras. It's ridiculous. Might be the 100. I think this is the 100. So yeah, anyways, if you're interested, the camera that I use is Sony, it's an AX1000 maybe. And, Sony camera. Come on. Let's see what Sony.com. We have detected you are coming from the United States. Well, good for you. Can I, oh, Jesus. Anyways, imaging, camcorders. So the one that I'm using is, I believe this is the one, or no?
X4K.
Yeah, so basically, but you can use whatever you want. I think it's the AX700. Again, I think that's the right one. Yeah, that looks about right. So this is the camera. Again, this is much better than you probably need. But what I didn't do plug it into is the Magewell. So Magewell is awesome if you haven't played with it. Basically, you can take any HDMI input and basically just turn it into webcam. So I have this little guy. So I have the HDMI cable running from the camera that plugs into this. I then have the USB-A that plugs into a USB-C adapter that then plugs in and then basically turns your camera into a webcam. And then I have a microphone on top of the thing. So that's how I do with the camera. Again, that's a bit expensive. Again, $2,000 or whatever, but I've been doing this for a while. So that's that. I don't know. This thing is overkill. This thing is overkill.
Okay. I guess I could just mount it on the wall and call it a day.
Well, don't necessarily do that, but I mean, like this was like $600. So, yeah, so it's StarTech. Let's see here. Amazon. So basically, what I would do is I go to anyways, I would go to Amazon.com, see what they have. So this is Hisense. So I actually have two of these. I really like these. Hisense at Best Buy. 65-inch 4K comes in around $400, somewhere between $300 to $500, depending on what the current sales are. So that's this. And then basically, if you have a 70 or 65-inch, you do need a stand that's big enough to hold it. That's where you get into the whole, boy, I have that mess. So, but you can get these for less than 200. So like this, remember I had the physical classroom, so I actually wanted these good enough I could use in physical classroom and fall over. So anyways, yeah, so Hisense, Magewell, that's about it. Yep.
Okay. All right. Thank you so much.
Oh, yep, no
That's my
problem.
last question.
Okay, fair enough. Let's see here. Christian, what's up?
Hey Eli, so I just wanted to say something. I tried out Ollama's OpenAI completions compatibility. So Ollama has this feature since February, I've seen on their blog, where you can actually use the OpenAI API. You have to tweak the constructor a bit when you construct the initial client. And obviously you can't use the GPT-4o model. You're going to have to use a model you actually have installed, but everything else stays the same.
Oh, okay. Yeah, I think, did you leave a comment on that before? I think maybe somebody did, yeah.
Yeah, I did leave a comment. I just want to let people know. I mean, in case their credit expired or they otherwise can't use the paid features of OpenAI, they can try the previous courses using Ollama.
Oh, yeah. Yeah, I'd seen you left that. Yeah, so client equals OpenAI. Oh yeah, look at that. Huh. So yeah, you can look
Yeah.
for OpenAI compatibility on Ollama, and yeah, this will show you basically how to format everything like you did with OpenAI, but use Ollama instead. Huh, so that's kind of cool. Yep.
Yeah,
Yeah, thank you for
yeah.
that.
Unfortunately, there's nothing for images that allows you to use the same syntax as OpenAI.
Yeah, 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 yeah. Yeah.
Yeah, for that you're gonna have to do something else, install a different stable diffusion model or communicate
Yeah.
with it.
Yeah.
Yeah, that's about it. That's what I wanted to add.
Okay, cool. Yeah, thank you for that. Yeah, I'd seen that, and yeah, I just hadn't had time to play with that one, but it does look kind of interesting. Oh, okay, okay. So has everybody finished the labs? I'm gonna start smacking some knuckles. Everybody actually do some coding. So it is actually, yeah, it is 4:20. So I've been staying on a little bit longer than expected. Are there any questions? Any questions at all? Because I have a long night. Outside of frame. Oh, it's gonna be a long day. So if there's any questions, I will take them. Let's see here. Eli, AI is literally transforming how IT companies work across all departments. It's truly revolutionizing all fields in a way it surpasses even the impact of NoSQL. Oh, okay. Okay. I'm just gonna walk away now. This is my problem. Like here in Asheville, we have like all these AI meetups. We have no other meetups. There's no other tech meetups. They're all AI. And then you go to the AI meetups, and then I just have to sit in the corner and keep my mouth shut. Remember, this field is about revolutionaries. It's about rebels. It's about people saying the exact same crap everybody else says in a revolutionary way. Remember, if you go to a tech meetup, what you need to do is you need to wear a t-shirt with Che Guevara on it, and then just nod your head and agree with what everybody else says. Because that's what a revolutionary is in 2024. So, anyways, I don't know. Everybody can have their own opinion. I will give you my opinion of AI. You do with it as you wish. Oh, so anyways. Yeah, so the next class that we're going to do, just so you all know, ooh, 2 weeks? It's going to be about 2 weeks away. We're probably going to do Bottle. So Bottle, Bottle. It's a framework for actually being able to create web apps. So it'll allow us to actually, create little graphical user environments, web, and you know what the fuck a web app is. Anyways, it'll allow us to create web apps. It's nice because it's a micro framework. So Django is a pretty large framework. There's a lot of stuff that goes to it in order to create a web app, which is great unless you're trying to teach it, that's a pain in the butt. So what I like about Bottle is it's pretty small, pretty simple. You just simply run the script, and that's what triggers the web server and everything else. So that is most likely what we're going to be teaching again in about 2 weeks from now. And yeah, that's all I got. That's all I got for today. So yeah, see y'all later.